Welcome to a recorded demonstration of the Time Machine product. I'm Raymond Watson with SolutionSoft, and today we're going to discuss Time Machine and setting virtual clocks. Virtual clocks allow you to test date-centric applications without changing the system clock, thus avoiding all of the complications that go with that. Virtual clocks can be set for users, for groups, and for process. There's several types of virtual clocks. We can set an absolute clock that goes to a specific date and time, either in the past or the future. We can set a relative virtual clock, 5 hours in the future or 20 minutes in the past. These clocks can be accelerated or decelerated up to 1,000 times faster or slower than the system clock. And we can go to any time zone around the world as our virtual clock. For the most part, the virtual clocks are set via a command line from the administrator or root user, depending of course if you're in a Windows environment, Linux, or Unix. For Windows users, whether you're the administrator or if your system has been configured to allow users to set their own virtual clocks, they can use the Time Machine GUI to do so. Here I'm going to set my virtual clock 9 hours into the future, and also several months out. And you can see the clock in the center reflected. Now the three clock faces that you see here are representing different users in our system. The top clock representing the SQL Server user, the center clock representing the user I'm logged into now, and a third user at the bottom. At any point in time I can revert my time back to the system clock, which you see reflected here at the bottom of the GUI. And then again, I change my time zone, just say to Baghdad. And you can see that it's already tomorrow in Baghdad. And you can see that time reflected in the clock on the right center. As I said a minute ago, the most common way is using a command line. And I have some of these most common commands scripted. I'm going to go through the script highlighting the commands, and we'll see the effect these commands have on various aspects of the system. The first one here representing the virtual clock in Baghdad time, and then we're issuing the command who am I. You can see my domain and user there. The tm user reset command clears all the clocks in the system, and the tm user -l lists all the clocks in the system, and after the reset there are none. Here you can see the command that we're going to issue frequently coming up in the next few moments, the SQL command, which is issuing the getDate function. You can see that reflects the system clock. After the tm reset here, you notice that all the clocks on the right hand side of my screen are in sync with the system clock, which is in the tray down here below. The next command is the tm user -a add u for user SQL 12/28/2359 in the year 2020. Now this clock is running at 10 times faster than the normal system clock. And as you can see by looking at the clock face in the upper right, this clock has already rolled over to leap day. The last thing that you see down here is us entering the getDate function and SQL Server providing us a timestamp of the virtual clock that was set for it, but it's already well past that. The next command is simply another call to getDate to show that we are on leap day, 6 minutes past the hour. If you watch that clock face, you'll know we're going to accelerate past 6 minutes quite quickly. Now setting clocks like this, we refer to these as ad hoc. Ad hoc because at system boot time, they're all cleared. You have a time machine configuration file, tmuser.cf, This is a more permanent mechanism for the clocks. Any of the clocks in here go into effect when the TM command is issued or at restart or reboot. If we look at the format here, Charlie has an absolute clock of October 1st in the year 2013 in the time zone that includes Paris. Right above that, Lori has a relative clock 23 hours into the future. Right below Charlie, there's a clock defined for the group QA, also an absolute clock, September 10th, 11:35, 2015. This clock runs at 100 times slower than the system clock. All of these having hashtags in front of them are commented. The one below here for the SQL Server user absolute clock of Christmas Eve is not commented and will go into effect with either a reboot or the TM command, which you see issued right here below. And it tells you the clocks were configured successfully and reflected on the clock in the upper right hand corner. Now at this point, we know we have a virtual clock for SQL Server, so if I connect, I've got a query in here that pulls the current timestamp register. And if I execute that, you can see that while the person's birth date was in 1972, current timestamp is off into the future by a bit in 2015 on Christmas Eve. So if you have database applications, the applications are date-centric in any way. If you're using the database for the date or time, this is the way to affect those applications and effectively test them in date or time-centric situations. I'll point out here that the clock in the upper right-hand corner has now rolled over to Christmas. And again, the tmuser-l command here, we have one virtual clock in effect. And again, we're going to make a call to the getDate SQL Server function. You can see that reflecting the virtual clock. So that concludes this portion. Next thing I want to do is come in here to the command prompt. So if I wanted to add another clock here, a relative clock this time, tmuser-a for add-u, and then my user, "9 hours into the future." How about that one? You can see the clock face on the right hand center reflect that. tmuser-l now lists 2 clocks. So at this point, if we were go to use Microsoft Word and insert a date time, now reflects the virtual clock, not the system clock. Now we also have the capability to exclude certain applications from the process. So like we have a TM user, we have a TM DXCL, which lists things in an exclusion list. So let's say you wanted to set a virtual clock for a user, you want certain things to be excluded. You can do so with this list. And just like we have a permanent configuration file for the TM user command, we also have one for the TM exclusion. Here's what that looks like. And if at this point we wanted to put Microsoft Word in the exclusion list, save the file, the tmexb command puts the exclusion list into effect. Now we have WinWord and the run DLL32 both in the exclusion list. So here, go ahead and insert date and time. You can see now that despite the fact that we have a virtual clock that is in effect showing us on the 17th. The actual system clock is running on the 16th, and that's showing reflected in Word because Word is in the exclusion list. The next thing that you might consider is, let's say we have a test environment that has 32 machines of varying operating systems. One of the ways that we are able to control that is with the Time Machine Web Console. Time Machine Web Console allows us to define systems and change the virtual clock for those systems. There are multiple configuration files. You can see I have 2 different host names with different users defined. I have another configuration file that has 3 other host name user combinations. All of those for completely different testing configurations. So if we wanted to change the time, a relative clock, say 7 years, 9 days, and 3 hours into the future, for these 2 users in host machine combinations, you can do so just like this. Now you can see what happens. We got a full success, and the clock on the bottom right now has reflected a virtual clock. We want to go ahead and reset that and do so, and again you can see the clock face reflecting the system time on the lower right. So that concludes our recorded demonstration of the Time Machine product. Thank you.